In the first problem, we're given the centripetal force acting on an object moving in a circle in a plane. That force is therefore the net force. We're given the mass, and we're given the mass of the object, and we're given the radius of the circle. From this information, what can we determine? Well, knowing that this centripetal acceleration is v squared over r, which is really where we want to start when we're talking about a centripetal force, we calculate, or we observe what we have to do to get the centripetal acceleration. We get the relationship for centripetal acceleration, and then from that we multiply by the mass, which we're given, to get the expression for the centripetal force. And the centripetal force, of course, is the mass times the centripetal acceleration, because the force is equal to the mass times that acceleration. So what do we know? We know the radius of the circle, which appears here and here. We know the mass, which appears here and here. And we're given the centripetal force. Centripetal force being the net, well, doesn't matter. Centripetal force is mass times centripetal acceleration. So we can do one of two things. We can find the centripetal acceleration knowing the force and the mass, and then we would know the centripetal acceleration and the radius, so we could find the velocity. Or we could just write this as mass times v squared over r, centripetal force being v squared over r, and we would know centripetal force, mass, and radius. We could solve directly for v. So we get centripetal force equals mv squared over r, so that v equals what? And what I'm doing now is solving this equation for v. Centripetal force is m times v squared over r. We solve for v, and how do we do that? Well, multiply both sides by r over m, so we're going to have r times centripetal force divided by m, and then take plus or minus the square root. So we have plus or minus the square root of centripetal force times radius over mass, and then we just work that out. Again, we're given the centripetal force, the mass, and the radius, so this works in a fairly straightforward manner.